Unit 9, Lesson 2, Video number 5. How can we use concepts that we have learned about basic functions like linear and quadratic functions and relate that to what we're going to be doing in this part of the lesson? So if I asked you to graph y equals 2x, there's different ways we could go about it. Some of you may start by plugging in values. You plug in -1, and that's the input. So -1 times 2 is -2. Plugging in 0, 0 times 2 is 0. Plugging in 1 to get 2, plugging in 2 to get 4. That may be how some of you choose to do it. Others may recognize that you prefer using the basic format of y equals mx plus b. And you don't see any number in back here, so it's like a 0. So you're going to start at 0. The slope is 2/1. So you're going to rise up 2 and run 1. Rise up 2 and run 1. And now I'm going to connect those points. And whether you graph in this form or you graph, I'm going to go to the right 1 and down 2. Here's 0, 0. Here's 1, 2, and 2, 4. It's the exact same graph. Now, if I take that same function, but instead of there being a 0 or a missing value behind the 2x, and I place a 1 there, what does that tell us to do? Again, some of you may choose to use this table process. So you're starting with the -1, 0, 1, and 2. And I'd like us to look at this. If I plug in -1, that's my input value, I get -2 plus 1 is -1. Plugging in 0, 0 times 2 is 0, plus 1 is 1. And we end up with 3, plugging in 2, I get 5. Now let's compare this. When I look at the output, I have the exact same input values for two different equations. Now the only difference is the number in back, which is called the vertical shift, is up by 1. So I went up from 0 to 1. Look at how it impacted the output values, or the y's. I increased by 1, I increased by 1, I increased by 1, I increased by 1. So realistically, if you'd never been taught the y equals mx plus b, you could simply take each one of these terms, or excuse me, each one of these points, and I could rise up 1. And by rising up 1, I now have a new equation. Well, that's a little bit off, but you get the idea, that matches this. Or maybe you chose again to go, I'm going to start at 1, my slope is up 2 over 1, up 2 over 1, and I could also go down 2 over 1, and you can see that this would match up with what I have here. Ultimately, all I did is I took all of the outputs and just brought them up 1. Let's look down here. Now we have the very basic quadratic or parent function for quadratics. And remember, we have a pattern here. And so I'm going to start with 0, 1, 2. So I plug in 0, I get 1. Or 0, I plug in 1, I get 1. 2 is 4. And I could go back the opposite way too. I could have -1. 1 second. I have a child who's stepping in. Okay, so I plugged in -1, I squared it to get a +1, plugged in -2, I squared it to get 4. I do want to say that a lot of times I have several students each year that are like, no, it doesn't work that way. If you watch here, I take -1 and I square it. Now I'm telling you that I get +1, but look, they get -1. And if they square -2, they get -4. That doesn't match up here. Remember that whenever you input something into the computer or into the calculator or computer, if it's a negative value, you have to put parentheses around it, and you can see the difference. Now we get that +1, and now we get that +4. And that's because when the calculator reads it in this form, it says take -1 times this value. Take -1 times this value. All right, so let's graph this. I'm starting at 0, 0. I'm going over 1, up 1, over 2, and I'm going to rise up 4. I'll do the exact same thing and the exact same thing over here. Now let's use this concept that I just introduced to you up above. So the concept up above, as it relates to this, says that when I look at this function, I want to take this vertical shift and drop it down 1. So all of the output or y values are just going to drop down 1. Drop down 1, drop down 1, drop down 1. This was at 4. We're going to drop it down to 3. This was at 4. We're going to drop it down to 3. And now this function would match this. Or if I came over here, I have -2, -1, 0, 1, and 2. I'm going to drop all of these down just 1 unit. So this goes to 3, 0, -1, 0, and 3. How can that apply to what we're going to do next? All right, so this looks a little bit different, and how it looks different is now we have a number in back that is either being added or subtracted. That's going to represent that vertical shift. And so what I'm going to do is I'm going to start by demonstrating where that is on the graph. So I'm going to go down 1. So it's like I'm taking the x-axis and I'm dropping it down a value of 1. This is my new midline. Now everything else I do, in my mind, I'm thinking of this as the origin. Think of this as the x now, and this is the y. Everything else we do will be exactly the same. So I'm going to start by identifying what is the period length. So I'm going to come off the side here where I have a little more space. I'm going to take 2 pi, and I want to divide it by what number is directly in front of the x. It's not just divided by 4, it's divided by 1/4. So I want to divide 2 pi by a b value of 1/4. I'll keep 2 pi there. Change division into multiplying and take the reciprocal of 1/4. So I end up with 8 pi. So 1 cycle is 8 pi. Now when I do the x scale, that's the distance from one step to the next, I'm going to take 8 pi. I'm going to divide 8 pi by 4 because there's 4 steps with both sine and cosine functions. 8 pi divided by 4 reduces to 2 pi. Let me put these in place. Okay, so I've gone ahead and I've put down each one of the steps, going 2 cycles to the right and 1 cycle to the left. And next is let's look at the amplitude. So the amplitude here is going to be 3. The absolute value is 3. So I know that for this sine function, it's going to be 3 above or 3 below as a maximum distance away from this midline of y equals -1. So 1, 2, 3, and then 3 above. 1, 2, 3. So I'll go up as high as 2, 1, 2, 3, 4, and down as low as -4. All right, let's get started. So I'm going to grab this. We're going to use this as I graph. This is a sine function. Notice that sine again is the second number here. So 0. 0 times 3 is 0. So think of this as my origin. I'm going to start at 0. 1. 1 times 3 is 3. So from here I'm going to go up 3. 1, 2, and 3. 0. 0 times 3 is 0. -1. -1 times 3 is -3. So from here I'm dropping down 3. And to complete the cycle, 0 times 3 is 0. So this is 1 cycle. Make sure it's rounded and you have your dots. I'm going to continue 1 cycle to the right and then also do 1 cycle to the left. Make sure you put those dots on your. Okay, this particular graph has a maximum of 16 pi to the right of the origin and -8 is going to be the minimum moving to the left. But we do see 3 different cycles, making sure we have arrows insinuating that this is a continuous wave curve function. Let's look at this. Let's now graph the function y equals -5/2 or -2.5. This is equivalent to -2.5 sine of 2 pi x plus 1. Very first thing I'm going to do is I do want to show where is my new midline. Okay, so I've demonstrated where we find this midline is 1. So we are thinking this right now is our x-axis and this is our y-axis. Think of this as our origin. So I've adjusted now for this vertical shift. Next, let's identify what is going to be the period or the length of 1 cycle. So I'm going to take 2 pi here and I'm going to take 2 pi and divide by directly what is in front of the x, which happens to be 2 pi. Well, that makes it very simple. That means the period for this function is simply 1. We don't say just cancels out. Remember, they're simplifying, so it simplifies to 1. So after 4 steps, because all sine and cosine functions have 4 steps, we're at 1. Now after 2, we're at 2, and then we're back here. Now what about the x scale? Well, I'm going to take it and always divide it by 4, because again, sine and cosine have 4 steps for each cycle. I know this is 1/4. I will fill these all in. This is 2/4. This is 3/4, and I'm going to continue to fill these in right now. 5/4. This is 6/4, this is 7/4, and 8/4, and then I will make sure to put the negative sign as I go to the left. All right, so 2 things to note. Yes, we have an amplitude. Amplitude describes the distance from the midline to the highest to the lowest of 2.5. So let's go 2.5 up. 1, 2, 2.5 is going to be right here. And 2.5 below, 1, 2, it's going to be right here. So 1, 2, 3, so it's going to go as high as 3.5, and it's going to go as low as -1.5. It's time to get started. Here we go. We are working with the sine function. So sine is our second number. 0 times negative 5/2 is 0. This is my origin. There's 0. 1 times negative 5/2 is negative 5/2. So from here, I'm going to go down 5/2, which is equivalent to 2.5. Down 2.5. 1, 2, 2.5. Okay, again, I'm working with sine. 0 times negative 5/2 is 0. And negative 1 times negative 5/2 is a positive 5/2. So in step 3, I'm going to go up to 5/2, which is 2.5 above the midline. And I'm finishing out the one cycle with 0 times 5/2, which is 0. So I'm dropping it down. And this is one cycle. I'm going to complete one more cycle to the right and one cycle to the left. Make sure. And I've completed graphing this particular equation with 2 cycles to the right, a maximum of 2, 1 cycle to the left, a minimum of -1. Let's go on to our final example. Okay, let's move on to our final example for this video. And let's start again with because I see a value behind, it's separated by addition or subtraction, I know this represents a vertical shift. So I'm going to drop down 2. All right, so I've identified where our new midline occurs. It occurs with the equation y equals -2. And now let's look at what is the period length. So I'm taking 2 pi and I'm dividing it by the value directly in front of the x, which is 6 pi. The pi's are going to be simplified to 1, and this will reduce to 1/3. 2 over 6 reduces to 1/3. Now for the x scale, or the distance, so 4 steps will give me 1 cycle. Keep in mind that this is a cosine and not a sine like our previous 2 examples. So the x scale, I'm going to take 1/3 and I'm going to divide it by 4. As a reminder, we're taking 1/3 and turning division to multiplying, and I'm going to get an x scale of 1/12. Now, what is the quick way of doing this? As a reminder again, we can grab that calculator, go 1 divided by 12 plus 1 divided by 12, and then we can simplify it, and we get 1/6. And I can add 1/12 again, and I get 1/4. And adding to it again, 1/12. Now I want to end up with 1/3. If I don't, I think I made a mistake, and you can see I ended up with 1/3. I'm going to press pause, continue out to 2 cycles to the right, and then write down the 1 cycle to the left. Okay, so I've used what value I was able to achieve for the x scale to demonstrate where I'll be at each step with going 2 cycles to the right and 1 cycle to the left. I can see that I have an amplitude of 3. The absolute value of 3 is 3. And now it's time to get started in graphing this. Notice that I need to go 3 above and 3 below the midline. So from here, I'm going to count up 3. 1, 2, 3. That means this graph will go as high as 3. And then from the midline, down 3. 1, 2, 3. 1, 2, 3, 4, 5. And it'll go down as low as -5. We are working with cosine, which is our first value here. I'm going to take 1 times 3. 1 times 3 is 3. So from here, I'm going to go up. Remember, this is like my new origin. I'm going to go up 3. 1, 2, and 3. Taking one step. 0 times 3 is 0. -1 times 3 is -3. So on step 2, from the midline, I'm going to drop down 3. 0 times 3 is 0. And on my final 4th step, 1 times 3 is 3. So from my midline, I'm going to go up 3. Remember, this is not a sharp V. It's going to be more of a rounded or U shape at the bottom. This is 1 cycle. I'll use dots and do 4 more steps to the right and 4 steps. So I've made dots in the appropriate places, and now I'm connecting.